morning children. In today's class we are going to learn about product of vectors. In the earlier classes we learned how to add the vectors, subtract the vectors and also scalar multiplication. That is, we learned how to add OA plus OB vectors. We learned how to subtract OB vector minus OA vector. We also learned twice A vector, 3 times B vector, minus 4 times C vector. Now we proceed on for multiplication of two vectors. So when I call A vector and B vector, when I multiply, there is a question. Is my answer scalar or a vector? So we have two types of product of vectors. When I say dot product or I say the word scalar product, say this is vector A and this is another vector B. The angle between them I call theta. In this case, how am I to define this A dot B? I say modulus of A vector, modulus of B vector, cosine of the angle between them. We know modulus is a number, a scalar. Cos theta, the angle between them when I take the trigonometric ratio, that is also a scalar. So the entire answer is a scalar. So I call this as dot product or in other words scalar product. What is the other one? We call A cross B vector. A, we never call it as into, we read it as cross. So A cross B vector. What is the formula for this? Again it is modulus of A, modulus of B, sine theta, and because it is a vector product, my answer should be a vector. We know mod A, mod B, sine theta are again scalars. So to give the vector notation, I give n cap. What is this n cap? It is a unit vector perpendicular to the plane containing A and B. See, A vector is on the board. B vector is on the board. Theta is the angle between A and B. Now where is n vector? It will be perpendicular to the board. So what do I say? N vector is a unit vector which is perpendicular to the plane containing A and B. So we have the properties of dot as well as cross products. Let us see into details. Properties of scalar product. As we know the formula A dot B is mod A, mod B, cos theta. B dot A will become mod B, mod A, cos of minus theta. A to B plus theta, B to A minus theta. But cos of minus theta is still cos theta only. So, A dot B I can write equals to B dot A and dot product is commutative. About the angles. If theta is 0, cos 0 is 1. So I simply get A, B. Instead of writing mod A, mod B, I can simply write A, B. So when theta is 0, they are in the same direction we say. When A and B are in the same direction, we have theta to be 0. When A and B are in opposite direction, the angle between A and B becomes 180 degrees. Cos of 180 is minus 1, so my answer is minus A into B. If A and B are perpendicular, so this is A vector and this is B vector. When the angle is perpendicular, we know cos 90 is 0, so 0 into anything 0. Similarly, if A dot B is 0, I can claim either modulus of A0 or modulus of B0 or the angle between them is 90. So, if A dot B 0, I can say A and B are perpendicular. If A and B are perpendicular, I can still claim A dot B to be 0. If the angle is acute between A and B, I can say A dot B cos of acute angle, so it is positive. If A and B are in obtuse angle, now theta comes in second quadrant where cos is negative. So A dot B is negative when theta is obtuse and A dot B is positive when theta is acute. A dot A. Apply here, it is A into cos of 0, or simply I get A square. This A square I can write in many methods. Whether I put vector and square, modulus and square, or simply A square. It is all one and the same, which will be useful while doing exercise problems. Now what about I dot I? Let us remember, we have the three different axes, x, y, z. So naturally, between I and j, the angle is 90. So I dot j 0. Between j and k, again the angle is 90. So j dot k 0. With a similar argument, we can say k dot I 0. But when I say I dot I, it is of this pattern, so I square. But I square is 1 because I, j, k are unit vectors along x, y, z, mutually perpendicular directions. When we have some scalars like this, I can keep them out or combine with A or combine with B, however I require in the problems. Distributive law, we have left and right. A dot B plus C can be written as A dot B plus A dot C. Similarly, A plus B dot C is written as A dot C plus B dot C. So this we call right and this we call left. We know the algebraic identities A plus B the whole square. As I apply in vectors, it is becoming A square plus B square. They are all modulus squares. But here, do not simply write 2AB. Rather, it is 2 times A dot B. So what is A plus B the whole square? Mod A square plus mod B square plus twice vector A dot vector B. The same idea with minus symbol also. When I have A plus B into A minus B, here I have A vector plus B vector dot A vector minus B vector. My answer is A square minus B square. So let us use these identities while doing exercise problems. A dot B, geometrically how am I to define? Consider, we have OA, A vector, OB, B vector, and angle between OA and OB is theta. Suppose I drop a perpendicular from B. So BD is the perpendicular dropped from B on OA. OD I call projection of B vector on A vector. OD, this distance, I call projection of B vector on A vector. In this right angle triangle, what is cos theta? It is adjacent OD by hypotenuse B. When I write the ratio, I must write the length of the vector, that is modulus of B. Cross multiplying OD, the length, that is the projection, is nothing but mod B cos theta. What is the formula we know? A dot B is mod A mod B cos theta. Instead of mod B cos theta, I can very well write OD. So what is OD? It is projection of B on A. So the formula for A dot B geometrically can be stated as mod A into projection of B on A. From this, what is projection of B on A? I can bring mod A down. So if I want projection of B on A, bring A down. If I want projection of A on B, bring B down. So we have a very important formula to be used in the exercise problems. Projection of one vector on another vector. Find the dot product of the vectors and divide by. On what? That should come in the denominator. So on B tells me modulus of B in the denominator. Some more properties. If I have A as A1I plus A2J plus A3K and B as B1I plus B2J plus B3K, how are we to find out the dot product? Let us remember I dot J, J dot K, K dot I, these things are 0 because they are mutually perpendicular. Only which vectors exist? I dot I can write 1, J dot J1, K dot K1. So when I say dot product, I need to multiply I and I, J and J, K and K. The remaining products become 0 by this reason. So if I multiply I and I get A1, B1. I dot I is 1. Similarly, A2, J component and J component. J dot J is 1 plus K component A3, B3. A very simple idea to remember. While performing dot product, let us multiply I, J and J, K and K. In your answer, I, J, K will not come. Remember, dot is a scalar product. In your answer, the vector symbols will not come. Now from this formula, I can also write what is cos theta. So what is cos theta from here? It is A dot B divided by mod A mod B. If I want only theta, bring cos to the other side. How does cos come to the other side? Remember, it comes as inverse. So theta is cos inverse of A dot B divided by mod A mod B. And this is the formula for angle between two vectors, say A and B. Now, modulus of A plus B is definitely less than or equal to mod A plus mod B. As we know in a triangle, if one vector is A, another vector is B. Naturally, the third side is A vector plus B vector. But we know the length of the third side is obviously less than or equal to sum of the other two sides. This we call triangle inequality. So when I say vector notation, I simply add them. But when I say modulus, I mean the length. The length of the third side is definitely less than or equal to sum of the lengths of the other two sides. And from this formula, where A dot B is mod A mod B cos theta, we know maximum value of cos theta is 1. So, cos theta is ranging from -1 to +1. From here, I can deduce A dot B modulus is less than or equal to mod A into mod B. Why? Because modulus of cos theta is less than or equal to 1. Let us proceed into exercise problems. Exercise 8.3, question number 1. Find A vector dot B vector when A and B are given. How are we to perform dot product? We need to multiply I and I, J and J, K and K. A dot B equals, here the number 1 into 3. Here the number minus 2 into minus 4. Here the number 1 into minus 2. I into I, J into J, K into K. In our answer, I, J, K will not come. It is a scalar product. So what is my answer? 3 plus 8 minus 2. That is 9. So we get A dot B equals 9. Second subdivision, we are given A and B. To find out dot product, A dot B equals 2I plus 2J minus K dot 6I minus 3J plus 2K. Let us remember to mention this dot, which is very important. It is not like ordinary maths problems where we simply write AB. Here A dot B dot counts a lot, do not forget. How are we to perform dot? I and I, 2 into 6. J and J, 2 into minus 3. K and K, minus 1 into 2. As we simplify, it is 12 minus 6 minus 2, that is 4. So we get A dot B equals 4, and that's the answer. Question number 2, find the value of lambda for which A and B are perpendicular. We know A and B are perpendicular if A vector dot B vector is equal to 0. As we substitute for A and B, 2I plus lambda J plus K dot I minus 2J plus 3K equals to 0. Dot product tells us to multiply I and I, 2 into 1, J and J, lambda into minus 2, K and K, 1 into 3, that is 0. So we get 2 minus 2 lambda plus 3, 0. Or minus 2 lambda equals minus 2 minus 3. Minus 2 lambda is minus 5, lambda is minus 5 by minus 2, that is 5 by 2, which is the answer. Second subdivision, given A and B, we need to find the value of lambda given A vector perpendicular to B vector. That tells us A vector dot B vector equal to 0. A vector is 2I plus 4J minus K dot B vector 3I minus 2J plus lambda into K equals 0. How to perform dot product? I and I, 2 into 3. J and J, 4 into minus 2. K and K, minus 1 into lambda, that is 0. 6 minus 8 minus lambda is 0. Minus lambda is minus 6 plus 8. Minus lambda is 2, or lambda equals minus 2. Question number 3. If A and B are two vectors such that mod A equals 10, mod B equals 15, A vector dot B vector is 75 into root 2. We need to find the angle between A and B. What is the formula for angle between A vector and B vector? We call it as theta. Theta equals cos inverse A vector dot B vector by mod A vector mod B vector. As we substitute in the formula, we get theta equals cos inverse. What is A dot B? 75 root 2. Mod A is 10 and mod B is 15. As we cancel, we get theta is 1 times, 5 times, 2 times. So we get cos inverse of root 2 by 2. As I simplify further, root 2 by 2 can be written as root 2 into root 2. Cancelling 1 root 2, we get theta is cos inverse 1 by root 2. Or we should recall from the trigonometric ratios table, cos of which angle gives me 1 by root 2. As we recall, I can say 45 degrees or pi by 4 radians. So cos 45 gives us 1 by root 2. So cos inverse of 1 by root 2 claims us to recall from the table 45 degrees, or I can say pi by 4 radians. Question number 12. Find the projection of the vector I plus 3j plus 7k on the vector 2i plus 6j plus 3k. As I recall the formula, projection of A vector on B vector is A vector dot B vector by modulus of B vector. Let us find out what is A dot B, also what is modulus of B. A vector I plus 3j plus 7k dot B vector 2i plus 6j plus 3k. And we remember dot tells us multiply I and I. 1 into 2, 3 into 6, j and j component, 7 into 3. As I simplify, it is 2 plus 18 plus 21. That is 41. Modulus of B. Whenever I say modulus, root of, add the squares. 2 square plus 6 square plus 3 square. As I simplify, it is 4 plus 36 plus 9. That is 49, and the square root of which we get 7. My question is projection of A vector on B vector. That is A dot B. The answer is 41. Modulus of B. The answer is 7. So we get projection of A on B is 41 by 7.